In 1969, the United States became the first country to successfully land humans on the moon. The rocket that carried the mission is still known as one of the most powerful rockets ever built by humans. But there is one fact that is rarely told about how America was able to develop rocket technology that advanced. One of the keys was bringing many German scientists and engineers to the United States, including scientists who had previously worked for the Nazis. But just how difficult is it to build a rocket that America needed scientists from another country to help develop it? The first problem is that a rocket has to move incredibly fast to overcome the pull of Earth's gravity. The second problem is that the rocket itself is extremely heavy, with its mass at liftoff reaching thousands of tons. That much weight can be equivalent to hundreds of elephants that all have to be lifted from the surface of the Earth at the same time. This means a rocket needs an enormous amount of power, and that much power requires a huge amount of fuel. The problem is, the more fuel that is added, the heavier the rocket becomes, and the more weight has to be pushed. A heavier rocket then requires even more fuel to generate enough thrust. This cycle keeps repeating, like a vicious circle that makes traveling into space extremely difficult. One important answer eventually came from a mathematics teacher in a small town in Russia. He believed that humans could not remain trapped on a single planet forever if they wanted to continue progressing. Even before the first airplane ever flew, he was already thinking about how humans could escape the trap of Earth's gravity. From his calculations, he noticed one simple problem that caused rockets to waste a lot of energy during flight. After the fuel was used up, the rocket still had to carry empty tanks and heavy structures that were no longer needed. From there came a simple idea. If a part of the rocket was no longer useful, why not just get rid of it? Unfortunately, at first, almost no one took the mathematics teacher's idea seriously. He was only an ordinary school teacher, while his research was published in a journal that was not considered very prestigious.
More than a decade later, major changes in Russia caused the new government to become increasingly serious about developing science and technology. A new generation of Soviet scientists then began reading those works about space travel again. From this principle developed the concept of multi-stage rockets, which later became extremely important in spaceflight. In this system, a rocket is divided into several sections or stages that operate one after another. When the fuel in one stage runs out, the engines and empty tanks in that section are released from the rocket. The remaining rocket becomes much lighter, allowing it to continue accelerating without carrying weight that is no longer useful. The rocket's energy can then be used more efficiently to carry the parts that are actually still needed into space. This principle helped open the way for space travel until humans were finally able to set foot on the moon. But over time, the solution of throwing away rocket parts after they were used created a new and extremely expensive problem. Imagine that every time your phone battery runs out, instead of charging it, you throw away the entire phone and buy a new one.
That is roughly how conventional rockets work, losing many expensive components every time they launch. To solve this problem, several companies began developing rockets with components that could be reused. One of the ideas was to make the very expensive booster able to return to Earth after completing its job. After pushing the rocket during the early stage of flight, the booster turns around and begins guiding itself back toward the landing site. Fins on the booster help maintain stability and control its direction as it descends through the atmosphere. Just before reaching the surface, its engines ignite again, but this time not to accelerate the rocket. The engine thrust is used like a brake to slow the booster's fall so that it can land safely. Because it is not immediately thrown away, the same booster can then be used again for the next launch. Some boosters have even been flown again dozens of times on different missions. The ability to reuse parts of a rocket helps dramatically reduce launch costs compared with previous eras. In the past, sending a small payload into orbit could cost an amount that felt like buying a car just for a single trip. With increasingly efficient and reusable rocket technology, that cost has become much lower. Scientists and engineers are still looking for new ways to make traveling into space cheaper and more efficient. There are concepts that try to launch vehicles using a system similar to a giant slingshot before the rocket turns on its engines. There are also ideas that use laser energy to help push spacecraft to extremely high speeds. There has even been a concept involving a series of small nuclear explosions to propel a spacecraft. Many of these ideas are still far from the rockets we can see flying every day. But the history of rockets shows that ideas that initially sound strange can eventually become technologies that open the way into space. And if technology continues to develop, traveling by rocket may one day feel much more ordinary than it does today. And as always, thank you for watching.